In the previous video, we covered in detail the main report document. So this is of the sample document. The previous video was specific about the full report. And if you didn't have a chance to look at that, please do, because that is where we cover the importance of windows and doors with regards to thermal comfort. Now, this video is about the outcome of that modeling and the recommendations we make for windows and doors. So of the package that you receive, we are looking at the Appendix C as well as the specs document, spec 2. I recommend looking at both documents in detail because Appendix C gives more of the why as well as more big picture information as far as what type of window and doors to avoid in order to avoid issues, and which kind of windows and doors to look for in terms of products to maximize your performance. And then the EMU specs provides the actual specs that you can send to a manufacturer to get your quote and to get a window package that matches what you received as far as the performance from the report. Now, starting out with the Appendix C, this is the document that provides the overview of the window specifically, and specific goals in terms of condensation avoidance, thermal comfort, air tightness, operability, cost optimization, just some tips, as well as some description of what the passive house grading is. This is where we illustrate the different grades for the efficiency of the frame. So passive house A, B, and C grades. Some details on how to install these windows and doors in a couple of different wall assemblies. So looking at to start off, I would recommend you watching this video. This is a free video that you can click to if you want to have an in-depth analysis or presentation as far as why windows are important for thermal comfort. Now, in terms of terminology, these two documents, both the Appendix C and the EMU specs, apply to all exterior windows and doors. The doors to a garage, doors to an unconditioned basement, for example, a hatch to an unconditioned space such as an unconditioned crawl space or an unconditioned attic. Those are all doors and windows that belong in the envelope of your building. So the same requirements for air tightness as well as R values or insulation capability or property applies to those as well. Something that blows people's minds sometimes is discovering that the door between the house and the garage has to be insulated and has to be airtight. And that's true because the garage is outside of the main building envelope. Same goes with the skylights, roof, light wells, and similar openings. We have some indication here as far as condensation avoidance and comfort. I advise you reading this. There's a lot of detailing needed, and do not expect a rep of a window product to necessarily be familiar with this information. Even if they rep passive house certified windows and doors, they may not know the passive house method in preventing condensation. So that's something that is very important for you to be aware of. We're going to talk more about that in the EMU specs document in the second part of this video. For air tightness, this is something that there are some types of windows and doors that are more airtight than others, or in other words, there are some window and door types that are more leaky than others. And if you just select a type of door or window that is by nature more airtight than others, you are improving the performance of your building as well as your comfort without really increasing your cost. So just to have a higher degree of airtightness, you want to select from the first half of this page. So fixed windows and doors, tilt and turn, hopper windows awning, casement, uh, in-swing doors, lift and glide, lift and slide. And mostly for the same reason you want to avoid the following. Single hung, double hung, they're very leaky. Traditional sliding windows and doors, they're very leaky. Pivot windows, doors, and skylights, there is no way to make a pivot door being airtight. And so if you want to have an airtight, high quality building, just avoid a pivot door or a pivot window, as well as multi-fold windows and doors and pass-through windows and doors. They are very leaky, very, very leaky, like about 10 times or more leaky than a tilt and turn window. So that's something that if you can avoid this type of windows and doors, you're gonna be better off, even if you don't have the budget to pick a more performing window package. Then operability, passive house requires at least one operable window or door for main room of prolonged occupancy, meaning bedrooms, offices, classrooms, kitchen, basically wherever you spend a long time. So you always want to have at least one unit that is operable so that you have the psychological comfort of being able to open the window if needed. For cost optimization, we have put some bullet points here because it's important to meet a budget and not to overkill and not to overspend. So in the first place, understanding what performance you need, and this is something that you would see in table 8 in the report. So that is where we address that thermal comfort analysis in combination with the design of the building and the location of the project. Because really understanding whether or not you need triple pane and whether or not you need an A-grade window is very important to control your budget. So in the second place, if you have many small windows and doors, that's going to be more expensive than having the same glass area with fewer larger units. That's something that we see day in and day out. You can reduce, you can improve your energy performance and reduce your cost at the same time by consolidating your window package into fewer larger units. That's something that is fairly new in the US as far as design. A lot of American architects and designers are still stuck to the standard sizes of windows and doors in the US, and that is fairly small compared to what can be done. And if you have the options of consolidating I'm not saying to give up areas of glass or give up views. Sometimes you have to, or you have to reduce that. But even if you keep the same amount of glass, if you have fewer larger units, that's going to be better performance and cheaper. So that is something very important. Then looking at the grading, it's decently easy enough to get a good glass. That being said, many American manufacturers are not there yet. But once you get to a good glass, whatever that means, the frame is the weak point of your window and door. And so this grading of the performance of these products is really related to just the quality of the frame, the thermal quality of the frame. A, B, and C is like in school, A is the best, B is intermediate, C is lower, and then less than C is not very good. And especially in the B group, down here you see there's multiple types of frames, starting off from insulated timber frame, then insulated UPVC, fiberglass, thermally broken aluminum, so on and so forth. So in other words, these windows perform similarly from a thermal point of view. Their cost can be significantly different because on one side you have the cost of the material. UPVC is cheaper than thermally broken aluminum. It takes less labor than timber frame, so on and so forth. As well as the other side of cost, and that is a huge one, is marketing. So in our experience, there's not a direct correlation between higher price leading to better performance, nor there is a correlation between better performance leading necessarily to a higher price. So this is one of the reasons why for the preliminary passive house review, we intentionally do not model a specific window or specific windows. We look at these grading ranges because this tells us what range of performance you need to get to your goals. And then you can add specific products. But if you wanted to compare window A to window B, that would be very limiting of the value of the report that you get. Whereas modeling by range of performance, you get much more value for your report. So this is something that is very valuable. And back to that table 8 in the report, this is what it refers to in terms of classes. The classes, if you want to see how they are rated, you have a link here that it can take you where the document is. Then some tips as far as how to develop the details, how to install windows and doors. Again, the construction details are not in the scope of the preliminary passive house review. If you're interested in construction details, including installation details for windows and doors, we have those under the email pilot program. You have a link here if you want to get more information. In this next couple of pages, we provide a couple of examples on how to install a window, a passive house window in a couple of different wall assemblies. And the big picture is we are trying to hit these bullet points here in order to maximize performance. So lining up the window in the center of the wall, being able to fasten the window or door to the structure part of the wall, most likely where nail flanges are not an option in terms of performance. Nail flange install is not optimal for performance, so we typically train builders to do better performance practices. And then going over the frame with insulation, insulating the shim space on all four sides. That's part of the debate, but we recommend filling in the shim space on all four sides, and then looking at the durable air seal where spray foam is not a durable air seal. This is one of the details in a double stud wall. This is a window, a plywood back. We have some information here just as an example. And if you're looking at a 2x6 with extreme insulation, this is another example of how this can be achieved. But again, if you are interested in installed details, we provide those under the email pilot program, and that's something that we cover as an option when we review the report together with the team and the client once the report is complete and analysis is done. This is for the Appendix C. The email specs is more a cut-dry document that you're probably going to use to share with your supplier and say, hey, please provide me a window package that meets this. This is what you send them. And you have some references here with regards to condensation avoidance and whatnot, air seal, the type of openings recommended, the type of opening not recommended. And when we talk about grading of the frame, that grading always refers to the operable window, meaning that the fixed window is going to perform better. The operable door, it depends, the swing door, lift and slide typically perform not as good. So this is that grade that I called out for my project. So a spec for an A grade operable means that the fixed window is also going to be A grade, whereas the door is probably going to be B grade or better. Lift and slide needs to be A grade, so on and so forth. This is important because some reps out there, they know that they have an A grade fixed window, and they may tell you that, oh, my window is A grade, but they are talking about the fixed window. When we talk about grading, we always refer to the operable window. So it is normal that the fixed window is better. It's not a plus, it's not a bonus, it's normal. So so that you can navigate to the office that you receive better. Then this is the glass that we spec. Again, we provide both the European and the American numbers for the U values, just because Americans and Europeans model the glass differently. And so if you're asking a European supplier versus an American supplier, they're gonna get you different numbers, and in order to compare apples to apples, you want to be able to navigate them both. That's why for the same glass, same identical glass, we provide the performance in European standard and the American standard, so that you have a way to compare apples to apples. That covers the Windows specs, and the next video is going to be about the ERVs and HRVs.